We spend most of our waking hours performing high-intensity cognitive labor in front of screens. Yet at the end of the day, despite sitting perfectly still, we are left physically exhausted by the invisible mental weight of our environment. Mental fatigue is a measurable physiological state. It is a distinct biological reality with clear neural markers, entirely separate from simply feeling sleepy or lacking motivation to work. When your brain reaches this state of exhaustion, it actively degrades your motor execution. Your physical endurance drops, and your movements become less efficient, even if your muscles are completely rested. You see the mechanics of this failure when an elite athlete suddenly loses coordination in the final minutes of a long game, or when an older adult experiences impaired balance, immediately increasing their risk of a fall. Traditional physical training focuses almost entirely on preparing the muscles. But because the brain governs all movement, an exhausted mind can easily override a perfectly conditioned body. Researchers are testing a counterintuitive intervention to fix this vulnerability. It is called brain endurance training, and it requires individuals to endure heavy cognitive loads during intense physical workouts. In a typical session, subjects are forced to cycle or run to the point of exhaustion while simultaneously solving complex memory tasks or rapid-fire decision-making puzzles on a screen. To evaluate the true effectiveness of this method, scientists aggregated the data from 11 rigorous peer-reviewed studies into a comprehensive meta-analysis. This Prisma flow diagram illustrates the filtering process. Researchers screened thousands of records to isolate a final sample pool of 438 healthy participants, with ages ranging from 14 all the way to 78. The compiled data answers a critical question. By intentionally stressing the brain while working the body, we can determine if it is possible to actively immunize humans against exhaustion. The researchers utilized a three-way interaction analytical framework. This allowed them to compare human physical performance across two highly specific states, testing subjects when they are completely fresh versus testing them when they are severely mentally fatigued. This chart displays pooled effect sizes. On the endurance fresh row, the diamond sits near 0, showing minimal physical advantage when rested. But moving to the endurance fatigue row, the diamond shifts dramatically right. Under heavy mental fatigue, the trained group demonstrates a massive physical advantage. This highlights the concept of performance fatigability. A normal control group's physical output plummets the moment their cognitive resources are depleted. The trained group remains highly stable under the exact same mental stress. This stability occurs in the central nervous system, where the brain learns to hold a steady physical output even as cognitive resources run dry. Brain endurance training does not raise a person's absolute physical ceiling. It builds fatigue resilience, preventing their physical floor from collapsing when the pressure increases. Beyond pure stamina, the researchers measured objective cognitive gains using the Stroop test, which evaluates a person's executive control and rapid decision-making skills under pressure. Returning to the chart, the top row labeled Stroop reveals the objective cognitive improvement. The trained group reduced their average reaction time by 56.62 milliseconds. While a fraction of a second might sound small, in high-speed environments, a 50-millisecond gap dictates the difference between amateur hesitation and expert execution. The study isolated variables maximizing these results. In this chart, the top left panel shows untrained individuals achieve much larger gains than highly trained athletes. Furthermore, protocols reveal a strict volume boundary. Regimens over 8 weeks yield the best adaptations, if occurring under 4 times a week. Because this protocol taxes the nervous system heavily, it requires a precise dosage to avoid cognitive overload. It acts more like medicine than a standard fitness routine where you simply push harder. The behavioral charts confirm that the method works. The next step is to understand the internal neurophysiology, determining how the brain actively manufactures this fatigue resistance. Inside the brain lies the anterior cingulate cortex. This region is highly involved in effort-based decision-making and processing the physical feeling of exertion. The prevailing scientific theory states that heavy cognitive load acts as a chronic stressor. Over time, this stress rewires and optimizes the cortex to tolerate higher levels of discomfort. The external physical load remains exactly the same. The body's central nervous system simply learns to maintain that physical output with a much lower neural drive. The feeling of physical exhaustion is frequently a protective illusion manufactured by the brain to force us to stop moving, rather than a true mechanical failure of our muscles. Stamina is a neurological skill, as trainable and specific as any cardiovascular metric. Whether you are an athlete in the final quarter or a surgeon mid-operation, baseline physical capacity becomes irrelevant the moment your mind is completely exhausted. Direct cognitive conditioning provides a layer of performance resilience that traditional physical training cannot reach. The data proves that the absolute physical limits of the human body are ultimately dictated by the endurance of the human mind.